Today we're going to do a problem identifying the basicity of amines. Today we're going to learn how to identify which amine is more basic and explain why. Here is our example. We have aniline here versus pyridine here. First, let's look at aniline. When we look at aniline, we know that the lone pair of electrons are on this nitrogen. We next need to ask ourselves, are these lone pair of electrons localized on that nitrogen, or they can be delocalized? Well, NH2 is an electron donating group, which means they donate this pair of electrons into the ring and forms resonance structures. This is the first resonance structure. Here you can see that the lone pair of nitrogen was pushed out to make the double bond, and this double bond broke to push electrons onto that carbon. This forms the next resonance structure, which is here this negative charge pushed the electrons to make a double bond, and this double bond broke to put the negative charge on this carbon. Next, you have the next resonance structure, which is here again, it did the same thing. This negative charge was pushed to make the double bond. This double bond broke to push the negative charge onto this carbon. And lastly, the last resonance structure is this resonance structure can move electrons, pushing this negative charge to form this double bond, and this double bond breaking to kick the electrons onto nitrogen to go back to the original structure. Therefore, we can say that resonance delocalizes the electron pair into the ring, so they are less available to react. Pyridine has lone pair of electrons on the nitrogen as well. However, these, you have to ask yourself, can they be delocalized or are they localized on the nitrogen? If you look inside the ring, you can see that there is 2, 4, 6 pi electrons, which falls into the 4n plus 2 of aromaticity. Therefore, this ring actually has aromaticity. Therefore, the electron pair is actually in an sp2 hybrid orbital, but it's not delocalized into the ring because of aromaticity, and so they are available to react. This brings us back to the question of which amine is more basic. Is it aniline or pyridine? When something is basic, they want protons more, and also their lone pair of electrons are more available to react. Looking at what we had just discussed, this means that our pyridine is more basic because the electron pair is in the sp2 hybrid orbital and not in the ring. This makes the lone pair more available to react. Thanks for watching!